Hello, my name is Zachery Washington, and I'll be taking you on a small tour of some of the art at my place of work. I currently work at Caltech, and I know we are taking an architectural tour of the school in June, but I thought I would show you a little of my art and the art that surrounds me every day. Recent advances in technologies have given the community at Caltech the ability to view this world in ways we have never been able to before. I tend to gravitate towards the concept of nature being art, so I thought giving you guys a look at what these advancements have allowed us to view in nature would be perfect. So I present to you Caltech, the Art of Science. To begin, I will show you just for a few seconds the art that I work on. May look a little boring, I know, but I assemble these chassis with my own hands and it feels like an art piece after it's finished. I begin with an empty gold casing without all the wires and boards, and after I drill some holes and solder some pieces, I fill it with all the guts and bring it to a working piece of machinery. I like to think that the colors of the different resistors on all the boards complement the complete symmetry. The wires remind me of neurons in our brains that send information, and all around it's just so easy to the eye. This is why I consider my work somewhat of a sculpting art. Next, we will explore some of the much more fascinating and beautiful work done by some of the people that work around me. Curly Yap, an undergraduate student at Caltech, played around with some experiments concerning the ability for a biological living form to be created through pure chemical forces. By mixing certain amounts of a solution containing a sodium silicate concentrate and a cobalt chloride powder, she was able to create cell-like formations. Thankfully, she took pictures as well because you can't deny that this is oddly beautiful. The range of color, formations, and structures are an art in itself. The bulb structures she described as being onion-like, each with a strand of collecting cobalt growing around it. When these strands hit the surface, the powder dries and takes a flower or lily pad type shape, all while maintaining a fascinating range of hues and randomness that I feel only you can find in nature. Ellen Yu, another undergraduate student, worked with a fluorescent protein called M-cherry that is used in biotechnology to track fluids, somewhat as a tracer attached to cells and molecules. What's sometimes funny about scientists is that they do things they don't necessarily need to do, like zap this M-cherry fluorescent protein with ultraviolet radiation. Ellen admits it virtually has no worth in terms of use, but why not zap the protein when it turns into bunches of cherry-colored crystals? Especially when you can take a picture like this. Not only are the lines in this photo are amazing, but the spiral formation forming on the left side is insanely fascinating. While some artists use a paintbrush and paint, I feel Ellen uses her tech and ultraviolet radiation. Finally, these next photos were some of my favorite to find. There are boards and chips being manufactured today that have a layer of woven DNA strands. These strands are woven into what's called a nanoscale maze, and luckily, through something called atomic force microscopy, we were able to see what these mazes actually look like. Philip Peterson took these two photos as 2D images, while the third photo is a 3D image that is almost like a topography photo of a mountain range on Earth. How he did this, I have no idea, but do I believe it to be an art? Of course. Symmetry seems to be a passion of mine, so I love it in these photos. But if you see in this last photo, there are also places of abnormality and difference, which I feel is an incredible sight.